The talk that we're doing today that he's going to be talking about and redoing is the stop naming your warehouses like they're pets. This was at the Data Cloud Summit, but it was on a very early time slot on a Thursday morning. Some of you who might have been at the conference weren't able to attend or had to fly out early. And so thanks for joining and coming back for this rerun. So without further ado, I'm going to hand over to Jacques. And again, if you have any questions, drop them in the chat. I'm happy to address those as we go. So thank you for joining, and over to you, Jacques.
Thanks, Matthew. So we're talking about your warehouses, your Snowflake warehouses, and really this idea that you shouldn't know their names. That most organizations right now know the names of their warehouses. And really, these are resources you're using. They're not really pets, and you shouldn't know their names. And so let's talk first about, we'll start by talking about cost drivers and opportunities. We'll then talk about a few common warehouse fallacies that we often see people have, and then talk a little bit about what you can do about these things and how you can avoid those fallacies. So let's first just cover briefly Snowflake cost. I think I've never met a person who says that their Snowflake cost, that they're happy with their Snowflake cost. Most organizations we talk to, Snowflake is an exceptionally good platform and is very, very helpful. But often people struggle with costs being higher than what they anticipated, costs being trending so that they have to redo their contract more often than once a year. And so what does drive that cost? Well, the first thing that we've seen with organizations is typically 90+% of all costs on Snowflake is driven by compute. There are other costs like storage costs and whatnot, but most organizations, the vast majority of their costs are driven by compute. Compute is driven by queries. Now, what's interesting about queries run on Snowflake is the vast majority of queries are run by machines, not people, for most organizations. When you look at it, typically, if you're looking at a volume basis, it's about 75% of queries are run by things like dbt or Fivetran or an ETL job that might be run by Airflow or something like that. But what's even more interesting than that 75% of query volume is that typically those are the more expensive queries that are running on Snowflake. And so most organizations we talk to, 90% of the credits that go to compute are actually driven by queries run by machines. Sure, there's definitely a bunch of people inside of Snowsight. There might be people inside of different dashboarding tools like Sigma or Tableau. But the reality is that the vast majority of consumption of Snowflake is typically driven by queries run on a schedule by machines like ETL jobs and that kind of thing. Okay. Now, what's interesting is that then if you compare that with what is the common warehouse utilization, we see that in most organizations, you frequently see a warehouse utilization of 50% or less. So that means that your warehouses are either sitting there entirely idle, or more commonly, they're sitting there underutilized, right? So you may have one or two queries running on the warehouse, which is keeping it up. But you actually could run, 8 or 10 or 15 queries in that warehouse to actually use all the consumption there. And so these are kind of the key factors that we think about when we think about cost. There are definitely other ways to solve for cost, but if you can target and improve how you're using compute, and you can target these queries that are running regularly by machines that are driving a huge portion of your overall consumption, then what you can do is you can drive up that warehouse utilization and ultimately improve cost. And so our observation in general is that the largest opportunity for Snowflake cost savings is effective warehouse use. If you can figure out a way to use those warehouses effectively, you're going to drive lower credit consumption. And then for most organizations, what that means is that you've become less sensitive about putting new workloads or expanding workloads on top of Snowflake. Doing that is the big opportunity that we see. Now, the question is, what are the impediments to doing that? Why is the situation the way it is that people's warehouse utilization is frequently low? And there are a few warehouse fallacies that we see people struggle with. Part of it is just, when you first start using Snowflake, you don't understand some of the dynamics. Also, when you first start using Snowflake, people are trying to give you the simplest possible way to use Snowflake. And so the first fallacy that we see people struggle with is the idea that you should mix warehouse strategies, okay? And what I mean by this is that warehouses are actually two different things in Snowflake. The first is that people are typically trained to use warehouses for accounting. So they're like, okay, I'm going to create a warehouse for this business unit or for this use case in this business unit. And you basically, and that Snowflake kind of has historically kind of trained people to work this way. And so you basically then inside the reports, all the reports have cost reporting for each of those different business units because it's mapped to an individual warehouse. Every time you have a new team or use case, you create a new warehouse for that team or use case. And then generally speaking, users are responsible for picking the warehouse when they're thinking about what they're going to do. Okay. So that's what I call warehouse for accounting. The second strategy is warehouse for efficiency. And this is about saying like, hey, you know what we want to do is we want to pack as much onto each warehouse as possible. And we want to assign queries based on their efficiency on a warehouse, right? What's the right warehouse for this query? And then you're only adding capacity to improve latency, as opposed to creating a warehouse every time a new business unit comes on. You basically say, hey, when is it that I actually need to solve for capacity challenges? Okay. These two strategies are commonly the most challenging tension that people have when they're working with Snowflake, because they've kind of been trained on the left-hand side, warehouse for accounting. But the reality is, if you actually look at the characteristics of these things, they're in direct conflict. If you're trying to optimize for efficiency, you don't really want to split things up by arbitrary business units, because warehouses are a physical resource, and you really want to focus on how to use those effectively. So that's the first fallacy. The second fallacy is that people often think about warehouses as serverless. And again, the pattern here is that, people say, hey, warehouse is only up when it needs to be used, right? And so that, I think naturally people associate that with serverless. Hey, if no one's using it, it's going to shut itself down and it's fine, right? And so the mental model people have is warehouses are serverless. Auto scaling is really just about latency. Do you want to have, more, have higher concurrency, so you auto scale up once there's more queries? And really this idea that adding warehouses is free. But if you actually look at the graphic that we have along the bottom of the screen, and you try to compare the different components inside of Snowflake with, say, different things that exist inside of Amazon, right? Well, in Amazon's AWS, Lambda is a serverless thing, right? So it runs for the period of time that you want to have something, but it doesn't run any extra time, right? There are things in Snowflake that are like that. So serverless tasks are very similar to Amazon's Lambda in that they run for the period of time that the task has work, and then they immediately stop. And you're billed for that on a per second basis at that level. And even materialized views is actually more consumption-based pricing than say something like Lambda or serverless tasks, because it's basically just the work. You don't even really think about the size of the compute unit or anything like that. When you look at Snowflake's virtual warehouses, they don't sit over there. They actually sit much closer to an EC2 instance, right? So if you think about an EC2 instance, you choose to start it up for some purpose. You run it for some time. It has capacity, right? So you can run multiple things on top of an EC2 instance. And that's actually true of a warehouse as well, right? If you start up a Snowflake warehouse, you can actually run many queries on there simultaneously, right? And so the physical reality is that warehouses have capacity, and you can't forget that. Auto scaling is actually really interesting because almost always it increases cost, because it increases the likelihood that there's going to be a warehouse that is underutilized, right? So if I have a query workload that scales between 6 and 10 queries, and a warehouse can hold 8 queries effectively, then every so often when I go to 10 queries, I'm going to get a second warehouse if I have auto scaling enabled, but that second warehouse is only going to be running 2 queries on it, right? And so you're going to have lower utilization as you auto scale up. And that is just a natural case, right, of things. Whereas if I said, hey, hold off on running those queries, then that would actually increase the utilization of the first warehouse. So turning on auto scaling almost always increases costs. And then as sort of a corollary to that, basically, as you add more warehouses, you are likely to decrease utilization of your warehouses because you're basically spreading things out, right? And so an analogy I use is that, like, if I have one bucket, right, and my bucket is a warehouse, and I fill it full of things, right? It takes me a certain amount of effort to fill it full of things. If I then choose to take that bucket and say, you know what, I'm going to have 2 buckets, and I'm going to put half of my things in each of those buckets, what do I have? I have 2 half-full buckets. And as you have more and more buckets and you're spreading rocks or whatever you have in each of those buckets, it makes it harder and harder to keep all of those buckets full all of the time. And so often, as you add more warehouses, you impact utilization. Now, the third fallacy is that people often think about adding more warehouses, and that adding more warehouses will help, right? Like, okay, I just need to subdivide things even more, right? And so most organizations start in sort of the optimist phase. They're like, got like one warehouse, and they're just using that, and that's working okay. But then they start to realize that, like, what, it's not big enough for a certain set of queries. I need more concurrency, whatever. And then they start to move to what I call the pragmatist phase, which is they basically create multiple warehouses. They typically will split by team or use case. And then organizations who really start getting serious about FinOps often will move into what I call the mad scientist phase. And so one of the surveys I did at Snowflake Summit when I was doing this talk, because you could have people raise their hands and it was pretty obvious, is I asked how many warehouses people had, how many people had more than 5 warehouses. Everybody raised their hand. I asked how many people had more than 50 warehouses, and probably half the audience raised their hand. And I asked the question, how many people have more than 500 warehouses? And a few raised their hand. And so I don't know where each person on this call is in that sort of different experiences. But the reality is that the natural tendency is to create more and more warehouses and actually think inside your organization as basically having having a organizational function, which is warehouse management. You actually start to have people who are focused on, hey, what is our strategy around creating warehouses and whatnot? And so there are definitely a bunch of customers I've talked to who have more than 1,000 warehouses. And that becomes a giant maintenance burden. And it's actually in conflict with, I think, a key reason that people like Snowflake, which is that, hey, they don't have to worry as much about the details. So those are the 3 fallacies that we commonly see, and they're some of the reasons that it becomes difficult to really use warehouses effectively and make sure that you're being as efficient as possible. We think that there's a better way forward. And we actually think that Snowflake has actually given us some insight into how we can move forward in a more effective manner. And so the first thing to think about is that, what is this warehouse thing and why do we have to size them and whatnot? And I think that the key situation you have with warehouses is that for every query, there's probably a best warehouse size, okay? And there's a curve that looks like this. Now, it may be in a different position for every single query, but basically, if you go with too small of a warehouse, like you're trying to save as much money as possible, you can actually hurt yourself because your queries start to spill. Let's say you're down in this extra small zone here, your queries will actually start to spill and potentially even have to retry multiple times in order to complete successfully, which ultimately drives up your cost. Then you've got sort of some warehouses where your stuff runs pretty well. And then you can start to pay for performance, pay a premium for performance, right? So maybe you've got a CEO dashboard that it's critical you have very low latency. For that subset of things, maybe you want to actually pay more than you're getting for performance just because you want to maximize the user experience there. And then at some point, you can actually throw resources at the problem and it doesn't change anything. So the query takes the same length of time on the extra large as let's say as the 2XL and the 3XL. In that situation, because these things are just more expensive for the same amount of time, as you move to larger warehouses, all you're doing is increasing costs without influencing your performance at all. And so what we're always trying to do when we're thinking about using Snowflake and trying to be as efficient as possible is trying to right size ourselves into this middle zone, okay? Most organizations do this at a workload level. They say, okay, for this particular workload, I think I probably need this warehouse size. Right. And part of that thinking comes from, this kind of mixed challenge of warehousing for accounting. Okay, this is a warehouse for this workload and warehouse for efficiency, where you're like, okay, let me figure out the right size for this warehouse. And when you think about that, you're still starting to think about these things kind of as named things. Now, if you look at how serverless tasks have worked historically, and this has changed over time, so it doesn't always work this way. But Snowflake actually gave us some key insights about how we should actually think about these things. And so here's a query actually against some of our historical data saying, hey, I want to see all the warehouse names that are longer than 55 characters because it gives us this nice little list here. And this is a bunch of warehouses that Snowflake created to run serverless tasks, okay? And what you can see is that none of these are memorable, right? These are not pet names. These are cattle, right? And so serverless tasks actually provides us a nice model for how we should start to think about how we want to run queries to avoid the fallacies that we were talking about earlier. Now, there are some constraints to serverless tasks that mean that we can't actually use serverless tasks for most of our workloads. So the first is that you can't connect with, say, a BI tool or an ETL tool and run a serverless task directly, because there's no API to say, hey, I want to run this on a serverless task. You have to create a task, wrap your workload, and then run it. And so if I'm running a BI dashboard, that ain't going to work. The second is that serverless tasks don't support concurrency, right? Like a serverless task runs one query and then that serverless warehouse is up for that period of time and then shuts down. And then additionally, like in serverless tasks, you really can't take advantage of local caching, right? So one of the benefits, and especially in an ETL workload, is that if I bring up a warehouse and I run several queries on it, I can populate the local caches and improve performance. And then the last challenge with serverless tasks is that they cost 50% more than normal warehouse compute, even though they don't have any concurrency. So great model, great way to think about things, but it in itself is not actually what's going to solve it. And so at Sundeck, we have this pattern where we say, you know what? Rather than thinking about, so the top is the old model. It's probably what most of the people on the team on the call are doing, right? Which is over on the right-hand side, you've got different warehouses with names that are business meaningful, right? Like the sales dashboard and the marketing load warehouse and the customer matching warehouse, prod DBT warehouse. And each of those warehouses has a size. And probably you figured out what is the right size for, what is the best average size for that warehouse for that workload. And then there's a team that's making static decisions about which workloads when should we create a warehouse and which workloads should go to each warehouse. Okay, so that's the old model. The new model, and what Sundeck suggests that you focus on is that rather than trying to make this decision at the workload level, that you actually have AI make the decision at the query level. Because the reality is that even in one of those workloads, there's a lot of opportunity for efficiency, because you will realize that if I pick a medium warehouse for the sales dashboard, let's say, right, it means that I probably picked that because a subset of those sales dashboard queries really need a medium. But then there's probably a bunch of other queries that don't really need a medium, but I had to pick a medium because at least a few of those queries need a medium, right? If I can do this at the query level, then the subset of queries that need the medium warehouse, I can run those to a medium warehouse. But all the queries that don't need a medium warehouse, I can run those on a small warehouse. And so what happens is, instead of basically focusing on the left-hand side of that first slide, or one fallacies, which is warehouses for accounting, you say, you know what, I'm going to focus entirely on warehouses for efficiency. And at this point, the names of the warehouses don't matter, because who's deciding where to put the warehouses is our walrus and not a person on your team. Okay. And so basically completely shifts how things happen. And what's key about this is that even if a query is optimal for a certain warehouse today, it doesn't mean it is tomorrow. So I may build up a use case, and then all of a sudden the data keeps growing for that use case. And so, let's say that sales dashboard made sense on a medium last month, but this month, actually a subset of those queries actually want to be on a large or an extra large. And so if a human has to make that decision, then you're going to go back and realize that probably after someone's complaining about the dashboard's performance or something like that. Whereas if you can use AI-driven approach to this, and basically use machines to decide these things, then the machines can actually see that this warehouse, this query actually no longer is fit for this warehouse, and we should actually move that around. And those things change over time. And so that's the basic pattern that we talk about at Sundeck. Now, I'm going to jump into a very short demo of this, and just basically what the results look like when you do this. And so I am now inside of the Sundeck UI. And what I'm going to show you here is that you can actually go and see this if you install Sundeck and you have this exact same visualization. And it actually will give you an overview of queries coming into your warehouses. You have different size warehouses here. And what we've actually done in this situation is we've set these warehouses up to start to use Sundeck's auto routing. And what you will see is you'll start to see queries moving. Okay. So you've got a lot of queries in your medium here. But what you'll start to see is more queries start moving down. If I can move this down here. So actually, let me pause it for a second. I'm just going to pick a query here. Let's see here. There's a query here. Yeah, so let's pick this query. Now we're going to start to watch this query as we're running through time. And so on a particular day, I don't remember exactly what day. I think we're on May 5th here in this example data set. But we start turning on the Sundeck auto routing to see what happens. And this visualization, every time these queries light up, that's actually an example query of that type running again on that warehouse. So you see these queries are running a lot on this warehouse. And as we get to, I think, around this area here, you start to see queries moving. And so that black box, currently still staying in this warehouse here, but we're starting to move queries over. We moved some queries to a larger warehouse. You can see that now we've moved this one to a medium warehouse, or sorry, a small warehouse. So we're actually moving that automatically down. So no users are involved here. We just said, you know what, that query actually maybe can run on a small. And now we've even moved it further down. So we've actually moved it down to an extra small. And so this is with no human involvement. That query basically, Sundeck was seeing that query come into the Snowflake cluster. And then over time, it started to make a decision that, you know what, this can actually be on smaller and smaller warehouses. And along the way, it's monitoring the performance of that query. The reality is that there's no perfect science to determining what is the right warehouse for a query. You actually have to see how it runs on different warehouses to make the decision. And that's why you really want AI to do that. And that's generally how people do it as well, is they run it on a certain warehouse size. They see how that performs, and then they'll actually adjust what warehouse size it's on based on how they see it perform. And so what is the result of this? Well, down here below, because I've selected this query, we'll actually see a distribution of the durations of that query. And what you can see here is basically initially for over time, we have a certain set of distributions of queries where it's basically running for, I think, 1 minute here. And then over time, we switch it. And so you can see these are colored by the different warehouse sizes. And so we go from this one here is a medium here, I think. Then we go to a small, yeah, there we go. Go to a small, and then we go to an extra small. And what you can see is that actually moving this to a smaller warehouse has had very little influence on time. In fact, on the duration level, it's actually slightly faster on the smaller warehouse. And this may seem counterintuitive, but it's actually more common than you think, because typically you can have more small warehouses to work on something. And so there's less contention to run that query. And so if you actually look at the cost of this query, you can see that as we move through the different steps of movement of this query over time, we actually see that the cost has come down because we are now running this on a smaller query. And you actually see that sort of dynamic here as well. So this is cost versus performance. And we can see that an extra small actually outperforms a medium. It doesn't perform quite as well as the small, but it's substantially cheaper than the small, okay? And the reason it outperforms the medium by so much is generally because if you look at this query up here, we have a lot of stuff going on in that medium. And so we're seeing basically the challenges of having high concurrency on a warehouse is even if the warehouse is larger, it means that there's more competition for those resources. And so ultimately the system said, oh, you know what, this is actually the right place to run that query. And so, as I said, you can log into Sundeck and try this out yourself. We automatically generate the data and you can start to understand what's happening with your queries today. And then by turning on auto routing, actually seeing how things change. So dropping back into the deck here, the results that we often see is, the first is you spend less credits when you're using something like auto routing as opposed to naming your warehouses. And that's because we can pack queries onto smaller numbers of warehouses and focus those queries on the warehouses that are optimal for each query. And then the second thing, and I think this in many cases is as important or more important, is that you can often complete your workloads more quickly. And that's because what we do right now, if you think about how we make decisions to put something on a particular warehouse size, is that I call it the best average warehouse size. If I have a workload like a dashboard or an ETL workload, there's a subset of those things that are very, very big queries for that workload. They're the biggest queries in that workload. They're the ones that are most resource intensive. And then you've got a bunch of queries that are smaller. And because you have to make a decision today at the workload level, people typically will say, I don't want to use the absolute largest one that would be appropriate for the 3 queries that need, like, let's say an extra large. Like, you know what, those ones can run okay on a large instead of running them on an extra large. And then there's a bunch of other queries that, you know, don't even need a large. But I'm going to pick a large because it's kind of in the middle, okay? And what happens is that if you actually pick the right, if you let AI to pick the right warehouse for you across the different queries, you will actually decide to put those queries that could benefit from extra large actually on an extra large. And so those complete more quickly. And you push a bunch of queries down to, say, an extra small. And typically, people are very nervous about how much they use autoscaling because it can cost a lot of money. Well, the reality is that if you can push a lot of queries to an extra small, you're more likely to be comfortable using autoscaling on an extra small. And so the combination of the two means is you can actually get more concurrency because you're more comfortable having autoscaling on a smaller sized warehouse, along with on the occasions where it actually does make sense to have a larger warehouse, you have it, but only for a very fraction of the time for those subset of queries. And so this is the kinds of automatic decisions that we want to make. And ultimately, in many organizations, the first two, the fewer credits and the faster queries, don't even matter as much as the fact that you no longer have to have part of your organization focused on figuring out what are the right warehouses for workloads and trying to constantly adapt and change those as workloads change and as new workloads come in. And that's reduced burden on things that we can actually have AI do. There's a lot of people who talk about AI and they're excited about AI and all the things that AI do. And there's lots of cool things out there. But my perspective on it is that like there are some really straightforward things like this challenge that AI has been exceptional for for a very, very long time. So let's use it, take advantage of it, and ultimately have a better experience for everybody. So anyway, so that's the idea behind what we're talking about when we say, hey, here's where you're thinking about warehouses now, and where we think they should go. So that's the end of my presentation. I am happy to answer any questions. I don't know, Matthew, if you've got any questions you've seen sent to you in the chat.
We do. We have a number of questions. So thank you for those who have already put in their questions.